Hello everyone, welcome to the data analytics workshop. Uh, can you guys please confirm on the chat window if I am audible? So once I get a confirmation from someone, we'll start off. Okay, I got a few yes sir. So let us begin with the workshop. So today is the day 1 of 3 of the data analytics workshop we are having. So what we would do is we'll just go and understand what the syllabus we have for the day 1. So the topic which we will be covering today will be introduction to statistics. So the primarily we are going to cover the statistical part of the workshop today. So tomorrow I'll be showing you a couple of demos of different softwares that are being used, say Tableau, Power BI, Excel and all those things. Today we'll be covering the theory aspect of it, and the area which we'll be covering today would be introduction to statistics. So in that we'll be covering about what population and sample is, what are variables and the different kinds of variables that are available, the different types of data that are available, the methods of collection of primary and secondary data, how industry basically collects these data and then gather insights on that. We'll also talk about different visualization charts that are available and that are currently being used. We'll talk about what central tendency is, how the measures of dispersion is taken care of, and a few concepts of correlation and regression. We'll not go in depth of what correlation and regression is as of now. Maybe by tomorrow we'll go in depth of what exactly these topics are. Okay. So if you guys, so a few ground rules. If you guys have any questions, you can post it in the chat window. What we would do is we already have a Discord server, we have a WhatsApp group. So all your questions will be taken up in that WhatsApp group as well as the Discord server, as well as you can directly mail to floxuseducation@gmail.com. So these things will be taken care of offline once the classes is over. So we'll be directly focusing on learning for these 1.5 hours, and after that all your questions and all will be taken care of by the team. So, and as well as your attendance and all will also be marked up on the Discord server, the WhatsApp chat as well as on mail. So those details will be shared to you by the team of Floxus. So that being said, let us start off with the workshop without wasting any time. Okay. So we'll talk about what statistics is. So statistics will basically refer to anything that refers to numerical information. So basically collecting, organizing, analyzing the data, describing situations and often purpose of decision making. So statistics has become very important in the recent scenario with the demand with the demand rapidly increasing because of the you can say because of the incident of data science and how data science has devastated or disrupted the entire industry, and the way data science is being leveraged by every nooks and corner of every industry. Statistics has become a core of all that. So if you want to develop your career in data science, or if you want to pursue your career as a machine learning enthusiast, you will have to go through these basic concepts of statistics. You have to be aware of these concepts of statistics, right? So we will talk about what statistics is, and so basically using statistics is how we read data effectively, we tell stories from the data effectively, we understand data. So once you are able to understand data and what data is exactly telling you, you can derive meaningful insights from the data, and those insights can be used up by the industry. You can give business information, or you can directly tell your business about what these insights are doing up, and these things can be used for transforming data into useful information for decision makers. Okay, so we'll talk about where exactly statistics comes into picture and how exactly statistics. So statistics is used everywhere in every industry for giving meaningful insight to the management, and management is heavily dependent on statistics for taking business from one point to the other. Alright, there are a couple of scenarios which has been mentioned here. Okay, we'll not go into this. So basically there is a Dakova framework, so this is very theoretical and is available everywhere. We'll not go into it. So we'll talk about what different types of statistics that are available. So we have descriptive and inferential statistics. So descriptive statistics deals with organizing, summarizing, presenting data in an informative way. So your exploratory data analysis part, the exploratory data analysis is basically when you see the data, you make charts with the data, and those charts will be used for basically conveying meaningful information to your business. So that is where descriptive statistics is being used. Okay, inferential statistics is basically being used for so inferential statistic deals with finding something about a population from the sample belonging to a population. So this inferential statistics will be basically used wherein you will be having the data. So you are basically going to infer something from the data. You are going to infer some objective from the data. There in the inferential statistics part comes into play. Okay, so there are a couple of examples. So this PPT will be anyway shared to you. You can look into what look into these examples in detail. So once you have this, okay, so we'll talk about what a population and what a sample of data is. So population is basically a collection of data. For example, if you have so if you are considering the entire voting population of India, say around 130 crore people are there in India, so that entire population, if you are collecting, if we are considering, so that will be called as a population. But the way in which the voting poll are done, so you have various voting polls by Nielsen's and other companies. So these companies, they don't go to 130 crore people in India and then tell about what will be the voting share by different political parties. What these companies do, they go to maybe around 50,000 people or say 70,000 people among these group of entire population of 130 crore people, and based on that they tell that exactly how much vote share will be for different parties, right? So what population is? Population is basically a statistical parameter that will be referring to a collection of the entire data set. So the entire data set will be called as a population. And what will be the sample? Sample will be a part of that data set. Okay, so if you look at the example which is mentioned here, the measure of population is called as a parameter, and yeah, okay, so the mean number of soft drink consumed by all students in a university, the proportion of 5 million, yeah, so the proportion of 5 million voters who voted for some president in US is 5 million voters. So the entire 5 million voters would be a population, and if you are considering, say, among these 5 million 100 voters, so those 100 voters will be the sample of that population. So that is what a sample and a population is. So if you are measuring a population, that will be called as a parameter, and if you are measuring a sample, that will be called as a statistic. Okay, so we were talking about 5 million people who were voting for Bush, right? So the 5 million was a population, and if you're talking about 765 Floridans who were voting for Bush, so that is a sample. So that is a sample which is a part of the 5 million people. Alright, so I hope what sample is clear. So population will be the whole. Okay, I will not go into depth of what exactly it is. I hope everyone is clear with what sample and population is, the basics of that. Okay, so there are a couple of examples which are given here. People can have a look into it and then get back to me if you face any problems with what the example is. Okay, so we'll talk about what variables are. So when you are dealing with data, so data will be basically divided into various columns or rows of data, right? So the different columns of data, so one column of data will represent one thing. For example, if we have data on employee and their salary, So the data which is presented to us will be employee ID, employee name, and the salary of those employees. Okay, so these three columns of data, so these three columns of data are having different properties, right? So the first column of data is employee ID, so that is a unique identifier of those employees. Second column of data is your basically employee name, so that is not a numerical quantity, right? So that is a name, so that cannot be directly used for doing any mathematical calculation. The third quantity which we have here will be employee salary. So employee salary is a numerical variable. So basically using employee salary we can do a bit of numerical, or you can say a bit of mathematical calculations, imputations in that. So variables are basically divided into two categories, called categorical variable and numerical variables. So categorical variables, which are also called as qualitative variable, will be non-numeric variables. For example, you can see a couple of examples mentioned here, such as gender of person, the state of birth, the brand of shirts used. So if you have different brands of shirts used, 5 or 7 brands of shirts used, so that will come under categorical variable. The reason why I'm calling it as categorical is because it cannot be used for performing any numerical calculations. Alright, the second kind of variable that we have is a numerical variable, and numerical variables are basically the opposite of what categorical variable is. So we can perform few calculations on it. For example, the amount of income tax paid, the weight of a person. So we can basically calculate mean weight of a person, the average weight of a person, the median weight, the standard deviation of the weights of a entire class, or such things can be performed on this, right? So that is called as a numerical variable. Okay, so going ahead, so we'll talk about what there are a few different types of numerical variables available. So one thing is a discrete variable. Discrete variables will be variables which are defined in whole numbers. For example, if we talk about the number of TV sets owned, so we cannot have 1.5 TV set, right? So it can either be 1 TV set, 2 TV set, or it will be in whole numbers. It cannot be any fractional numbers, right? So it is called as a discrete variable because they can directly be counted and they cannot be done in a basically a decimal part does not come into play. And the second is your continuous variable. So continuous variables are values that arise from measuring process, and values depend on the precision of the measuring instrument. For example, if we are going to measure the length of a line using your scale, okay, so a typical scale which we use every day, so that scale is having the precision to be in millimeters. So it will measure the line's length in maybe 7.65 centimeters or something like that. It will not be able to measure in any further to what in more than the millimeter. Okay, so if you want to do a measurement in nanometers or some other different ways for measuring, so we'll be needing different instruments for measuring, right? So such variables are called as continuous variables. So for example, see, time spent on checkout lines or rainfall in a state. For rainfall in a state could be in centimeters, in millimeters, or meters. So that will basically depend on what the measuring instrument is. So that's the reason it is called as a continuous variable, because we cannot measure it accurately. So the accuracy of measurement will completely depend on the precision of the measuring instrument. That's the reason it is called as a continuous variable. Okay, so we'll go ahead. Here anyway we have mentioned out the variable type, but if we ask you a question, so you can ask yourself a question. The first question will be, do you have a Facebook profile? What will be your response? It will either be yes, no, or can't say you don't want to disclose that. So such variable would be a categorical variable, right? It cannot be a numerical variable. The yes and no cannot be a numerical variable, right? How many text messages have you sent in the past 3 days? So it will be numerical and discrete. If you guys understood what the definition of discrete and a continuous variable is, you guys would be able to answer to these questions very well. So the third question is, how long did the mobile app update? How much time did the mobile update took place? How much time did it take for mobile to get updated? So the response will be either in seconds, or minutes or nanoseconds or milliseconds so on and so forth, depending on the kind of measuring instrument you have. So it will be a numerical variable, but then it is going to be continuous, because we are not going to measure it we can only measure it as precisely as a instrument we have in our hand, right? Alright, so I hope your discrete variable and continuous variable part is clear, so we'll go ahead. Alright, so we'll talk about the different types of data. And again, the reason why we are dealing with these things today is because tomorrow we are going to have various case studies. So these things will come in very handy once we are discussing those case studies. Otherwise, you people will be very you people will be lost in what I am going to explain in the case study. Right. So once you have an orientation in what the kind of data is, how the different types of variables that are available, you guys will have a better experience, a better understanding of what data analytics is and what exactly the case study is going to be all about. So the case study, I'll try to keep it a bit interactive so that I want input from you people as well on how we should go about it. So today, okay, so let's go ahead. We'll talk about the different types of data that are available. So there are 4 types of data: nominal, ordinal, interval, and ratio level. So nominal is the most basic form of data that is available, followed by ordinal, interval, and ratio. Ratio is a good type of data, and we can basically infer or basically derive a lot of information from a ratio level data if it is presented to us. How? We will talk about it. Okay, so let's talk about what a nominal data is. So a nominal level data is as I have written down here, it is the weakest of all data measurement, and so basically the categorization is the main purpose of this measurement. For example, if you see, there's a business school that is there. So finance has been labeled as 401 and MBN system has been labeled as 402. So these are the subject codes of these 2 subjects that are being taught in a business school, right? 401 and 402. So what does these 2 numbers denote? These 2 numbers are just denoting the subjects, finance and MBN systems, right? So they do not donate anything else. So again, if we talk about a simpler example, the various brands of toothpaste, for example Colgate or Pepsodent or anything, so those brands of toothpaste that are there, so these toothpaste will only represent the toothpaste brand, nothing else. Okay, so this is just for the purpose of categorization of a different quantities. We are using nominal level of data, right? And as discussed, it would be the weakest of all the data measurements that are available. Okay, so going ahead, now we'll talk about few examples of what a nominal scale data is, the different types of investment, the network providers, brand of shares. You can see the categories and all those, the names of these things. So these are will come under the nominal scale data. Alright, so here are further few more examples of that. I'll not go into details of those. Second is ordinal level data. For example, everyone has studied through schools and everyone remembers that the top 10 ranks that are given to students, right? And also the grading system that are available in school: A grade, A plus, B minus, and all those things. So such gradings, such gradings are given to a few categories of maybe students or few categories of different professors or something like that. So such level of distribution will come under the ordinal level of data. For example, the example which is mentioned here is, for example, we are having rating as superior, good, average, poor, and inferior. The frequency of such professor is, so what do we mean by frequency? Let's talk a couple of minutes about that. So superior has been given a frequency of 6, which means that there are 6 professors in a particular college who are rated as superior, and there are 28 professors who are rated as good, 25 professors who are rated as average. So what does this entire data represent? The rating of the professor and the division of the professor based on the different ratings will represent a ordinal level of data. That's all. So we are basically labeling out. So what information was presented to us? The information presented to us was that there are 100, say 100 finance professor in a college. Okay. Now what we did, we had a survey and people responded as 6 are superior, 28 are good, 25 are average. So we'll just add. So we are representing the data in this format, and we call it as an ordinal level of data. All right. Okay, let's go ahead with the next topic. Few examples have been given. Please go through these examples, and if you are having any confusion as to why this is categorized as an ordinal and not a nominal level of data, you can ask those questions in the Discord server. Those three communication channels which I just mentioned in the beginning, either the Discord server, the WhatsApp chat, or through mail. You can ask those questions and we'll get back to you as soon as possible. Now we will talk about interval level of data. So what is an interval level of data? For example, if we say that the temperature is between 940 degrees and 960 degrees. So what is the difference between these temperatures? 20 degrees, right? You can refer to this example. I'm trying to read it out. Right, so the temperature difference is 20 degrees, and if we talk about 1000 degrees and 1020 degrees centigrade, the difference is again 20. So these are intervals 940 to 960 and 1000 to 120. The intervals is only, the difference in intervals is 20 degrees only. So this isn't called as an interval level data. Okay, so I'll also give one more example to make it a bit clear. So okay, so we are measuring the time of a day on an interval scale. Like, we cannot say 10 a.m. is twice as long as 5 a.m., right? We can only say that between 5 a.m. and 6 a.m. there is 1 hour gap, and between say 9 a.m. and 10 a.m. there is 1 hour gap. But we cannot say that reaching to 10 a.m. will be taking twice as longer as reaching to 5 a.m. or something like that. We cannot say that. But what we can see is that the interval between say 12 a.m. and 10 a.m. is twice as long as the interval between 12 a.m. and 5 a.m. We can talk only in intervals. We are not like, we cannot do any multiplications in these. We cannot do any multiplication and say something is twice as long as something else. We can only talk about the intervals of data that are available, right? So that's the reason it is called as an interval level data. Okay, the next is the ratio level data, and it is all the quantitative measurements that we do. So the general measurements that we do, for example, so we calculate the wages of laborers, the market share of a company. So such things will be called as a ratio level data. For example, someone is earning 40,000 per year and someone is earning 80,000 per year. Then it will mean that he is earning half as much as Rob. Jim is earning half as much as Rob because he is earning 40,000 per year, and Rob is earning around 80,000 per year, right? So in ratio level data, we can perform all our quantitative calculations, all our mathematical calculations, right? Right. So the one thing which I would like to mention is in between the interval level data and the ratio level data, what we have is ratio level data will have all the characteristic of an interval level data. I said that it will be twice as long as this, right? So ratio level data will have all those characteristics, but in addition to that, the ratio of the two numbers which will be shown to you, they will be meaningful. The ratio of 40,000 and 80,000 will deliver some meaning to you, right? Ratio of salary of 40,000 and the ratio of salary of 80,000 will deliver some meaning to you. But in case of interval level data, 10 a.m. and 5 a.m., if we have a ratio of these two time, it won't deliver any meaningful information to you, right? Okay, so that's the difference between interval and ratio level data. Okay, so let's not waste time in talking about hierarchy of data. And okay, so data collection is an important topic. The most of the time of a company, or the statistician in a company, most of the time goes in data collection, because making a model is the most easiest part. So once you go and dive right into what data science, to the world of data science, you'll understand that the collection of data, cleaning of data takes a lot more time than the creation of model, and then the creation of model and deriving insights from the data and all. So once your data is properly collected, so collection of a proper data is necessary if you want to derive meaningful insights. So basically, the better the data, the better the insights, and the better your company performs. Okay, so there are different ways in which data is collected. So the person who is collecting data will be called as an investigator, and the person who is providing data will be called as a respondent. So respondent basically provides data to the investigator. So based on the collection, data is divided as primary data and secondary data. Okay, primary data is if the data is collected for the very first time. So if I give you a Google form and I ask you to rate me as to how the seminar is going between 1 and 10, and you give me a rating of 5, 7, 5, 6, 7, 8, 9, something of that sort, so that data will be called as a primary data to me, because I'm collecting it for the very first time, right? Okay, so that data has not been collected by anyone before, as I said. So if just refer to what I just said. So collection of the performance in this webinar has not been collected by anyone before. So if I collect that data, so that will be collected for the very first time, and it has not been collected by anyone before, and it will provide me as an investigator, if I'm collecting that data, with the most reliable first-hand information about the respondents. So it will give me the most reliable information from you people as to how the seminar is progressing and how you people are liking the seminar or not liking the seminar, right? And I can collect that data directly from you people, or I can ask anyone from the team of Floxus to collect that data. So if I'm collecting it directly, so that will be internal to me, and if I ask someone else to collect that data for me, so that will be external, right? It will be external. So that is what internal and external here means. Okay, so let's talk about how primary data can be collected. So there are different ways in which primary data is being collected. Many companies are using these techniques. This is being used by many years for the collection of primary data. Okay, so the first thing is direct personal investigation. I can directly reach. So just refer to the example of me sending a link for collecting information about how the workshop is progressing. Okay, so first thing is the direct personal investigation. I can reach out to you people individually and then understand about how basically this workshop is progressing. We can conduct an indirect oral interview, either by telephonic or an indirect respondent to maybe by telephonic interview or something. So we are collecting indirect oral interview and then collecting our data from you. We can mail the questionnaire to you. So basically I'll send a mail to you people, and then you can respond to with the what the score of this webinar would be. So this is how primary data is being collected. Okay, so other thing is schedules. So this will involve face-to-face situations with respondents. So I will be questioning you in the form mentioned in a form known as a schedule. So I'll be sending you a form which is called as a schedule, and you can basically fill out this questionnaire and send it back to me. And other thing will be I'll give it to some local agencies who will be collecting the data and then giving the entire data back to me. So this is how primary data is basically collected. It's pretty simple to understand. Okay, so secondary data is referred to as a data if the investigator is collecting from some other source. Okay, or maybe from past investigators or agent that is already collects the data that has been already collected by someone. So if I'm using that, so it will be called as the secondary data. Okay. There are problems in clarities and issues about intricacies of data. There might be ambiguity in terms of sample size and sample technique. So these are the problems that we can face if we are collecting secondary data. Okay, so it can be collected from published sources. Published sources means, for example, tier of Indian cities, tier 1, 2, 3. So that data is published by the government of India every year, or maybe every 5 years or 10 years. So that will be published sources of data. Unpublished sources of data is like it will not be from a particular source. Okay, such data is stored by some institution or private firm. For example, any MNC in India will be having information of the employees who are working in that MNC, and those information might not be public information, like how the employee is performing, the bands of those employees, whether A banding, B banding, C banding, the categories of the employee. So such data will be very private to the MNC in which that employee is working. Okay, so that data will be from an unpublished source. That data is not publicly available for everyone. So and it is called as an unpublished source, right? Okay, so we are done with what exactly data is. We'll talk about some details about what visualization of data would be. I will talk about few charting options and few other options as well. Okay, so if you look at this entire data, and if I talk about what can you infer from the data. Okay, I have mentioned it out because as of now we are in a learning phase. So few things which we can infer is this is the lowest and this is the highest value that is available here. So we can also tell that the value is in the range of 15,000 to 35,000, right? These are the two things which we can talk about. Okay, and we can also say that last month, on an average, if we find the sum of the entire numbers which are available here and divide by the number of numbers that are there, we can find out the average vehicle that is sold. We can talk about the maximum vehicle that was sold. We can talk about the lowest vehicle that was sold. We can talk about the range of the vehicle that was sold. Okay, so representing data in this format does not give you any idea about the things which I just talked about. Okay, if we are showing these things in the form of a chart or in the form of a table or at least in a form of a written text, the people will understand. But if you present this data in this form, people will have no clue as to what exactly is going on, right? All right. Okay, so these are a few mathematical calculations. I don't think this is very important. We'll not talk about relative frequencies. Let's go ahead. We'll talk about what histograms are. Yeah, okay, so let's talk about visualization of data, and we'll also talk about histograms here only. Where exactly? Okay, so in visualization of data, alright, so we'll talk about the summary table which is presented here, and the summary table basically shows the reason, a couple of reasons, and the percentage of people who are responding to those reasons, right? So better price is needed by someone. For example, this is from some online shopping website. The reason is why the people are buying is because they are being provided with a better price, because they are avoiding holiday crowds or hassles. So such reasons are being given by the shopkeeper, and the percentage of shopkeeper who are responding to such reason is given out. So once you have this will be a better way of representation of data than if you are having the entire data set. Imagine people who are so imagine we have a couple of people who are responding better price, then someone responding inconvenience. So the entire data set is given and we don't have this percentage. The entire rows of data is given. That will not give us any meaningful insight of it. If we have it in this form of a table, or if we have a pie chart made out of it, it will be a better explanation to the data. Okay, let's talk about a couple of things which we can do from this data. We'll talk about what a bar graph is. Yes, we should talk about that. Alright, so what is a bar graph? If we have a categorical variable and a numerical variable, so basically if we have a nominal variable or an ordinal variable available in front of me, I can basically make a bar graph. A bar graph, for example, if you are having different states and how these states are number of nuclear weapons that are available with these states, we can represent it in the form of a bar graph, and this graph will show that US is having the highest number of nuclear weapons, followed by Russia, then France and China and all those. So such data is better represented in a bar graph than than any other form of graph that are available. We'll talk about the limitations of bar graph as well. Yeah, so if we see that living arrangement, so living arrangement has been represented in a form of a bar graph, shows married people 70 something, 72 number of married people are here, and around 15 people who are living alone, and 10 people are living whose living arrangements are not known to me. So this one example, this is another example of a bar graph. Okay, let's talk about what the problem with this bar graph is. Okay, so this graph is represented, this graph is basically show the calories of common candies. So these are the different names of candies that are available, and this will showcase the different frequency of candies that are being eaten, or the calories that these candies have. Right? So what is the problem with this graph? You guys can write down in the chat window. I'll have a look after the session. And I'll also explain about what exactly the problem is with this graph as far as I am concerned. So there is no logical coherence in the display of this graph. You cannot make out as to what is the, you cannot make out anything from this graph. You cannot make out whether the skewness of the graph, I'll talk about what skewness is. We cannot make out the skewness of the graph. You cannot make out which is the highest, which is the lowest. It is very haphazard. In place of doing this, if we have something with the lowest calorie value in the first and followed by the other highest calorie value in the last, so if we have something in an ascending order, this graph will be better represented, right? So such visualizations comes in very handy if you are going to present this information to your management. Your management generally does not have time to spare for this particular small graph, right? So if you are presenting this data in a crisp and a proper manner, the management will quickly understand it, and that is exactly what a management is looking ahead for, right? Okay, so we'll talk about what the problem with this graph is. The problem here is it has been arranged in ascending order, almost in an ascending order, right? But again, there is some problem with this graph. Can you guys tell me where exactly the problem is? Okay, the problem is so there are a couple of questions. Labels are not marked clearly. Okay, so labels are basically Somaditya Singh. The labels are not marked correctly. I do understand that. But the idea here is not to understand what the labels are marked. The idea here is that there are a couple of things that are available in the x-axis, and there are calories that are available in the y-axis, and this basically represents the different types of chocolates that are being used by someone and the calorie level of these chocolates, right? Okay, so the idea is not to understand what is present in the x-axis. The idea is to understand that there are a lot of things that are present in x-axis, and the only reason, the problem with this graph is that because there are a lot of things present in the x-axis, we are not able to make out what exactly these things are, as has been prompted by Somaditya Singh. So that's the problem with this graph, right? So instead of doing this, if we are having, say, these number of the things which are represented in the x-axis and the things which are represented in the y-axis, if we change the axis of these things, then we will be able to explain this graph better, right? Or if we are looking at some other form of representation, say if we are only looking at the most important chocolates, the last bit you can see these are having the highest calories, right? So only if we are representing these 4 or 5, last 4 or 5 graph in those chocolates, these chocolates will basically be more meaningful for the management, because these are having the highest number of calories, and they can be questioned from the health department of the country that why these chocolates are being even eaten by someone if it is having such high calorific value, right? So representing the half bit, maybe we can break the graph into 2 or 3 graphs, showing that the first bit is having the lowest calories, the second bit will be having the average calories, and the third bit is having the maximum calories. If we basically break these graphs into 3 different graphs, it will become more meaningful, right? So that's the problem. You are not able to make out anything out of this graph. So that's the problem I have mentioned. Okay. So we'll go ahead and we'll talk about what the Gantt chart is. A Gantt chart is basically represent the one more way of representation of this. So if we are representing what is present in x-axis to y-axis, you will be having a better visualization. See, one second. You will be having a better visualization here. You will see that, okay, so these are the chocolates which are on top, and you will be able to read it better, and you will be able to understand the calorific amount of these chocolates better, right? So we will also talk about the pie chart. All right. Okay. So a pie chart, right? So pie chart will so basically we use a pie chart when there is percentage of data shown, and for example, you can see the different courses and the attendance of a particular person is given. So in computer science he is having the entire course attendance has been given. So computer science is having 18% attendance, statistics is having 16% of attendance. So we can also talk about the population of different states in India. So the percentage of population of the top 5 states in India. So that can be represented in the form of a pie chart. So if you want to represent a less number of variables, that can be either, as has been mentioned here, as a nominal or ordinal variable, and also shows percentage of categories. So such things can be represented in a pie chart. Alright, so the problem is, if we are having too many categories, of ordinal variables, we will not be able to make out anything head or two out of the pie chart. So we should never use a pie chart when we are having too many categories. So once we are dealing with data tomorrow, I'll show you the problem with having too many categories. We'll also make a graph similar to this, and we'll understand that, okay, so this cannot be used, you cannot infer anything from this particular graph, right? So here we should not use a pie chart. We can maybe use a Gantt chart here and then understand about the categories and the distribution of these categories, or we can skip a few categories or club a few categories into maybe one category. So the category which is having very small maybe percentages, such categories can be clubbed into one, and then we can have a better view at this chart. So we'll do that in Tableau as well tomorrow. Yeah. So we have mentioned comparison of bar chart and a pie chart. You can read about it, and we'll also talk about what a Pareto chart is. Let me go directly to the chart and then we'll talk about it. Okay. So a Pareto chart basically is, let's talk about what this graph is representing. Okay. So this is representing the problems of the insertion of card and such problem with the ATM card, and this part represents the frequency of that problem, right? So first problem is card jammed. So once you are withdrawing money from an ATM, your card can get jammed, your card can become unreadable, ATM can become malfunctions and ATM does not function well, ATM can be out of gas, invalid amount of request. So these are the problems that is available, that arises once you are using an ATM. Okay. And this shows the frequency and the number of times that problem occurs. What we also have in addition to in a Pareto chart is, so this will basically showcase the so if we are considering the entire number of let's see if we have the data. Yeah, we have this data as well. So the data has around 724 entries. 724 people were maybe taken as a sample and then it was calculated. So out of the 724, 365 people have faced the problem of card getting jammed in an ATM. So what will be the percentage frequency? The percentage frequency is 50%. Why I'm telling that? Because it is around 365 out of 724. So the percentage has been calculated as 50.41%. So this will basically represent the frequency. So the reason, the most important reason for using a Pareto chart is because the card jammed is having the maximum number of value, and this represents the 51%, and as you go ahead it will basically add on these percentage and reach to a cumulative 100%, as has been shown in this graph. the cumulative percentage is also shown in a Pareto chart. So that's the benefit of using a Pareto chart. You can actually make out as to how the different categories are moving along while reaching to the 100% of the 100% of the cumulative percentage, right? Okay, so there are few comments that is mentioned here. So the comment basically has the reason to why. So this you can directly explain that, okay, so card jammed is the most prominent problem that a customer faces once he uses an ATM. Alright, so okay. So we'll talk about few of the measures of central tendency. So the first thing is very easy, arithmetic mean, everyone knows about it. We add up all the value that is present and we divide by number of value that is present. So that is an arithmetic mean. And arithmetic mean for a group data can be calculated as we multiply the frequency with the observation and then we divide with the total number of observation. So such formulas are there. We don't basically need formula in tomorrow's class if when we are dealing with the case studies. So that part will be taken care by Excel or Tableau or any other platform that we are using tomorrow. Okay, so we calculate the arithmetic mean, we calculate the arithmetic mean of group data. So arithmetic mean I have explained. So weighted mean is the weighted mean basically will be calculated when there are different weights that are given. Okay, so laborers will be having different labor hours per unit per product, right? So unskilled labor will be given 5 rupees, semi-skilled labor will be given 7 rupees, and skilled laborers will be given 9 rupees, right? So the average of this would be 7, but average of this would be 7. Okay, so let me look at a couple of questions if you guys are having. Okay, so Somaditya Singh is asking that how is the cumulative percentage useful in reading the data in Pareto chart. Okay, I will scroll back to that and talk about it. Okay. Okay, so cumulative percentage is something which we calculated here, right? So we have the frequency 724, we have the percentage frequency, and cumulative percentage will be nothing but, so 82 is nothing but 50 plus 32.32, that is 82, right? So cumulative percentage basically explain how exactly is the data moving. So if we talk about card jam and card unreadability, the difference between these two is more compared to the difference between card unreadability and card malfunction. It is 82 and 87, right? So if you see the basically this line, what you can see is that the slope here is higher and the slope basically recedes as it is moving ahead. You cannot see it much clearly in this graph, but then if you plot something like that, you can see that the slope is receding, right? So just by looking at this data, you can understand that, okay, so this is representing 50% of the entire data. So this will represent around 20-30% of the entire data, and that is basically getting reduced as we are moving ahead. So the cumulative percentage will basically show that the difference between these things is getting receded as we are moving ahead, and that's the reason we are plotting cumulative percentage here, which is not clear with the entire data. The entire data only shows that this is receding. How exactly it is receding will be shown by cumulative percentage, right? Yes, we see if we are mentioning just the question from Anirudh, why we are not mentioning just the percentage frequency. So if we are mentioning just the percentage frequency here, the problem would be the percentage frequency will be 50%, 32%, 4%, right? It will not showcase a trend as to how we are moving ahead, right? Just mentioning the percentage frequency will not showcase how we are moving ahead, right? So if we talk about Pareto chart, let me deal with a few basic concepts as well so that you people understand better. So Pareto chart will help us to identify the vital few categories. Okay, so the vital categories are we are able to understand the vital categories. from the many categories that are available, right? So we are able to identify the first two categories are the most important one, and it also states that out of the observation in many data set, few categories represent the majority of data, while other is representing relatively small or trivial data, which I just talked about. And then it talks about, okay, so we are plotting cumulative percentage, and cumulative percentage will be plotted in midpoint of each category. So that is how a Pareto chart is plotted. Yeah. Okay, so that's about it. So we will move ahead. We have quite a few things to cover. Okay, so we were talking about arithmetic mean, we were talking about group data, and then there is geometric mean. So these are formulas. Median. So median will be the middle value from the entire data set. What is the middle value will be the median. So median is the middle value, and then I guess you guys are clear with what mean is. Mean will be nothing but average. Median will be the middle value, and mode will be the value which is occurring for the most number of times. Okay, so these are the very basic things which everyone knows from right from class 10 onwards. Okay, so there are two kind of plots that are plotted up. So there is left skewed data and right skewed data. So what exactly is a left skewed data and what exactly is a right skewed data? So we'll talk about it in detail in the next few slides. So yeah, so let's so the idea here is that most of the data points are most of the frequency of the data point is available in the second half, so in this part of the data, and in a right skew data most of the data will be available in this part of it. How it is varying and how exactly it plays a role, we'll talk about it. Okay, we'll talk about the measure of dispersion. Okay, so we'll talk about a couple of things here. Hold on. Okay, so these three curves, okay, why dispersion is important, what exactly is dispersion, we'll talk about that. Okay, so these three curves are having the same mean, right? The first curve and the second curve, and this is the third curve. All these three curves are having the same mean. Okay, but curve A has less spread. Okay, the curve A is relatively lesser spread than curve B and curve C. Okay, so from any data, the central tendency will help us to know about the characteristic of data. To increase our understanding of the pattern of data, we must measure the dispersion, spread or variability. So the reason why we are measuring dispersion of data is because if we just measure the mean of these three curves, all the mean will be same. For curve A, let's say the mean will be 20, for curve B the mean will be 20, and for curve C also the mean will be 20. But if you are talking about how spread across the data is, the length of this data, for example, C, it could be the age of people who are eating chocolates. Okay, so the age could be between 0 and 100. B could again be the age of the people eating a particular type of chocolate, but then that the age is not 0, right? The age could be something maybe 12 or 13 years, and it follows till say 70 years and not 100 years. A could be the people eating a third kind of chocolate, and it could vary between 20 years and 30 years. 20 years and 30 years, but the mean of these people are same. So how do we understand which chocolate category is being eaten by which person? So that can only be understood if we are measuring the spread of the entire data. So that becomes very important, measuring of the spread. Okay, yeah, so as I talked about, if we just measure the range, it will be misleading. So we are measuring mean deviation and all. We are not going to deal with this in this class because it's not important from tomorrow's class perspective. Okay, so we'll talk about what a correlation is and why correlation becomes important. So basically, if we are talking about two variables, say employee grade grade of the employee in a company, and the salary that the employee is getting. The grade of the employee would be, so grade basically is whether the employee is an associate, employee is a business analyst, or he's a manager, a senior manager, or a director level employee. So this basically represents the grades of the employee. And Y represents the salary. So just by looking at the data, can we say if there is a relationship between these two things, and what is the strength of this relationship? Is it very highly related to each other, or is it very it is not related to each other? Okay, let me open Excel. It will be a bit easier for me to explain. Okay, suppose we have a data, say employee name, and in the next column we have salary, and in the third column we have grade. Okay, so we have name as ABC, salary will be something of this sort. Okay, so first is an associate, second is a manager, and the third one is a director. Okay, so we want to understand whether these two things are related, whether this is related to this, or whether this is related to this. What is the relationship between these things? So to understand these this relation, okay, if it is not visible, I'll just increase the size. So the relation between these things is called as correlation. So correlation means if we talk about this column and this column, how this two columns are related to each other, or say how these two columns are related to each other. Okay, so if we talk about salary and grade, it is a common understanding that as your grade improves or as your grade increases, your salary will increase, right? So if that is the case, we can say that there is a positive correlation between these things. Right? Positive correlation means that once a variable is changing, once a particular variable is changing, the other variable is also changing in the same direction. Right? So it will be showing a positive correlation. If we talk about name of an employee and the salary if that employee is getting, do you think there will be any relation between the name of the employee and the salary that he is getting? You don't earn a salary based on your name, right? You earn your salary based on your grade only. So as the name of the employee and the salary of the employee does not have any relation in between them, these two things will not show any correlation. Correlation means this two will not show any relation among each other. So the name may change in any form. The name may the salary has no relation to the name of an employee. So that means that there is no correlation between these. Right? So this is what the basic concept of a correlation is. We'll talk about it in depth. Let me start showcasing the PPT again. Okay. So I talked about the basic statistical technique as to what exactly correlation is. There are a few examples. Okay. So we'll talk about a couple of examples. The first one is the stock of two airlines may rise and fall in any related manner, right? For example, if you talk about Indigo and AirAsia, so these two airlines, the stock of these two airlines may be related to each other. For example, if AirAsia does not perform well, okay, if AirAsia is not at all performing well, the number of seats getting occupied in Indigo, that increases significantly, and if that increases, the stock prices of that airline will increase because that is being used more than AirAsia. Or if there is some problem with say Indigo, some director level problem, some directors are changed or something of that sort, so that may lead to fall in the stock price of Indigo, but would mean an increase in the stock price of some other airline, right? So it will be some way these two people are related. Such examples are also mentioned. Other examples are also mentioned here. You can have a read. Okay. So let's talk about the DVD percentage and the movie attendance. The DVD percentage is slowly increasing, and you can see. So let's talk about what exactly this is. I hope we have a plot related to that. No, we don't have a plot, so let's not waste time reading that. We'll directly talk about what the plot represents. Okay, so this plot represents a scatter diagram between the blood pressure and weight of a person. Alright, this basically represents the blood pressure of a person, and the x-axis is representing the weight of a person. What we have done is, let's talk about this particular x which we are having here. Okay, so this is around 69, the weight is around 69 kg, and the blood pressure measured is around 125 or 130 millimeters. The pressure is measured, so the BP is around 130, right? So what we have done is we have just measured we have just plotted the numbers in a scatter plot. Okay, how exactly do we read a scatter plot? We'll talk about in the next slide. Alright, so once we have represented these numbers here, and we have many more people who have participated in telling us the weight and the blood pressure that they are having. If we measure all those things and we plot it here, it will be called as a scatter diagram. And scatter diagrams are of three types. Okay, if the scatter diagram is similar to what is shown here, the first one, it is called as a positively correlated relationship. If the scatter diagram is shown in this direction, it is called as a negatively correlated relationship. And if the scatter diagram is shown at the third one, it is called as no relation, because it is completely haphazard. It shows both positive and negative, if you can see here. So it will be having no relation at all. Okay, so this is what a positive, negative and a no correlation is. Positive correlation is, again, it will be in this direction, increasing with the number of hours. So what basically this represents, the number of hours which is spent studying is slowly increasing in the x-axis in this direction as my mouse pointer is moving, and the final grade in the course is shown increasing in this direction. So as the number of hours spent in studying increases, the final grade that you score in a particular course also improves. The more you study, the better grade you get. So that will represent a positive relationship, right? So okay, so we'll talk about what a negative relationship is. So the price of dollar, okay, over the year, okay, the car price in dollars over the year is shown decreasing here, right? That means, like, when the car is new, the price will be around, say, $9,500, and that gets reduced significantly as the age of the car increases. If the age of the car becomes 6 years, the price will correspond to around say $5,000, $5,500 or something of that sort, right? So this basically shows that there is a negative relationship between age and the price. So when you say negative relation, it means that as the age of the car is increasing, the price of the car is getting reduced, right? So which means that there is a negative relationship between the age and the price. Okay, so when we talk about no relation, the example could be the weight of a person in pound to the pulse rate of the person. Okay, it can be anything, because the pulse rate of a person changes randomly. If you start running or if you are idle, the pulse rate will change anyway, the pulse rate can change, right? So that will not have any correlation. The weight of a person will not, the pulse rate will not depend anyway in the weight of the person. So it is having no relation at all. So here are a couple of formula which talks about the variance and covariance. We don't need it, Excel will take care of it. The PPT will be shared. If you have any specific problem with regards to this formula, you can get in touch with us. We'll try to solve and give you an answer to that. Okay, Pearson's correlation is not important as of now. So talking about the coefficient of correlation, this becomes important from tomorrow's class perspective as well. So once we are measuring correlation using the formula which was shown in the previous few slides, the measurement will come in between 1 and -1. Okay, so if the measurement is coming between 1 and -1, the closer it is to 1, So 1 will represent perfect correlation. You can talk about 1 being 100% correlated, which will basically means that the two variables are 100% in relation to each other. The way I showed this, the salary increases with the grade. If the salary is continuously increasing as the grade is increasing, then it will be showing 100% correlation. Okay, if it is falling between 1 and 0.75, it will show strong correlation, and so on and so forth. If it is 0, then there is no correlation, and weak correlation, intermediate correlation, such things are there. Formula will calculate your R using the formula which is present above. Otherwise you can use Excel. Excel directly calculates correlation, and then the main idea is to infer what the data is trying to tell you. And once you see the correlation value, you will be able to tell that okay, so this particular data will tell that the correlation is so and so on. Okay, so R square is coefficient of determination. We are not going to deal with that as of now because that is not important. Acha, so the one thing which is very important is that correlation does not imply causation, which means that you can, okay, so let's talk with the help of an example only. You can say that as the grade is increasing, the salary of an employee is increasing, right? But you cannot tell that the increase in the grade is causing the salary to increase. Alright, or let's take a better example here, right? Wait, where is that graph? Here. Okay, so you cannot tell that as the car price is receding, okay, as the number of age of the car is increasing, right? As the age of the car is increasing, so that is not causing the price of the car to drop. So correlation will not signify that. Okay, where is that slide? Yeah, so if two variables are linearly related, it is not meaning that x will be causing y or y will be causing y. It may mean that another variable causes both x and y, that causes y, or that y is causing x. Correlation will not mean that it is a cause of occurrence of something, right? Correlation does not say that. Correlation just only tells that okay, so these variables are in relation to each other. That's all. Okay, so we are going to talk about the last bit today, the regression coefficient, the regression and why regression becomes important. So using correlation, we are able to measure as how a particular variable is related to another variable. We are not able to exactly measure the other variable with respect to one. Okay, I guess I'm sounding so you guys would have been confused with that. So correlation will tell you if there is an association between variable x and y, but it will not allow you to predict one variable from each from the another variable, right? It will just plot a scatter plot. So that scatter plot will not be you will not be, for example, so if you have a scatter plot in front of you, you will not be able to predict anything out of it, right? Regression is basically used to predict one variable using the other variable. For example, using regression, I will be predicting the salary of an employee using the grade. Okay, for example, we have another director grade. I will be able to predict the salary of the director grade based on the previous. So there will not only be one director, there can be many directors who will be having salary of something of that range. Something of that range, don't consider it to be a same number, it can be any number. Okay, so using these many data set, I will be able to predict the salary of the next director which is going to be hired. So regression comes into picture if we are going to do that. Okay. So what exactly it does, I will showcase with the help of a graph. So we were plotting a scatter plot in the previous correlation topic that we were dealing with. So we were plotting a scatter plot. What will regression do? What will regression will try to force fit a straight line between the scatter plot, so that the distance between, so this distance and this, the distance between individual points of the plot and this line gets reduced to the max. Okay, for example, what exactly I mean is, once I am plotting this particular line, so once I'm plotting this line using regression, I will ensure that this line is having the least distance between these circle. So there's least distance between this circle and the line. If you draw perpendicular distances between the circle and the line, the average distance should come least when we are plotting this entire line. So that is what my agenda would be when I am regressing a particular variable to another. So once we are doing that, what exactly we are doing? So there are few individual component here, the above one, and there are few component here in the lower end. So we are trying to force fit a line here stating that all these component on an average will lie on this line if we are drawing a line. So why will that be of our help? So once we are force fitting a line y is equal to ax plus b, and we know any of the variable, say if we know some variable, the age of the car, we will be able to predict the price of the car. For example, let's go to the car example and let's talk about it for a minute so that it becomes easy. Okay, so we were talking about the car example. So what exactly we do in regression, we will try to basically draw a line here. Look at the way my mouse is moving. We will try to draw a line here such that all these points on an average will lie on the line. So if we do that, and if everything is considered to be on the line, we can basically use the formula y is equal to mx plus c, and then we will be able to find the age of the car. If we know the age of the car, we will be able to find the price. If you know the price of the car, we will be able to find age. So that's the reason regression becomes important. Okay, so that line is called as the best fit line. The reason I'm telling you this is because tomorrow we'll be performing a regression exercise, and once we perform regression using, say, Excel, you will be able to understand how exactly this particular line is made, and you will be able to predict a variable using the other variable. You can predict a variable using the data of your own. Okay, so let's go to the least square regression. Is not important and not of any use. Yeah, it is just like we are trying to explain that and understand how exactly b can be found. Not important. Okay, I guess we have come to an end. I guess we have nothing else to discuss. If you guys have any specific queries or and all, you can type it in the chat window. I'll try to take those up, and we'll also talk about what we are going to cover in the next class. So till the time I'm talking about what we are going to cover in the next class, you guys are free to type on the chat window. We'll try to take a few questions there, not all, and the rest of the questions will be handled by the technical team of Floxus. Okay, so the syllabus and the area which we are going to cover tomorrow would be, we'll talk about few basics of advanced Excel. We'll not talk about basic functions that is present in Excel. We'll not talk about what exactly these things are. These are rows and columns. So those things should be known to you. Basic formulas and functions which are available here should be known to you. And if you have any specific doubt, we'll try to basically cover that. So we'll talk about a few advanced concepts in Excel, such as we'll talk about linear regression in Excel and correlation in Excel. We will talk about how pivots and advanced pivots are made. So basically, if I am plotting a pivot table here, so we'll talk about how slicers can be inserted, timeline can be inserted, how basically we plot a pivot chart and how it can be used. We'll talk about those things tomorrow and how it becomes important. We'll talk about what these are, what pivot table fields are, how the values can be changed. We'll go to value field settings and we'll talk about it tomorrow. And other than that, we'll also talk about what VLOOKUP and HLOOKUP is. It comes in very handy if you're part of an MNC or any place. This VLOOKUP and HLOOKUP comes in very handy. If time permits, we'll also talk about a couple of things in the data group. We'll talk about what if analysis, forecasting, solver, and all. So all those options will be enabled, and we'll talk about those things here. We'll talk about what text to column is and how it becomes very important. Data validation is also very important. We'll talk about the data tab of the Excel, because this is very handy. This comes in very handy if we are dealing with data analytics. Excel comes in very handy. You might not be doing a lot of concept, which I'll be talking about tomorrow. We will also take up two case studies, two important case studies, which will be very interesting. So first is the exit poll case study, how exit polls are getting calculated. So recently we are having a election in Kolkata, so we'll talk about how exit poll was calculated, maybe last to last government, how exit polls were calculated. We'll talk about that. We'll talk about with the exact data of that poll. The data is from Nielsen. And we'll also talk about predicting college student admission and their conversion chances in a particular college. We'll have data of different students, and we'll talk about whether this student will be getting placed or not. We'll try to talk that, and we'll also try to talk about which student will be getting admission to a particular college or not, if we are able to predict. For example, if a college is having, say, maybe 2000 application, and among 2000 application the college wants to choose 500 students, how these students are going to get chosen, and which students should get chosen, is what my model will try to predict. So that has been made. The first poll, so both of these case study will be based out of Excel only, and we'll see how the advanced Excel concepts and how these things are basically implemented, and we deal with these things. So with that, I have come to an end to today's webinar. Let's see if you guys have any questions. We'll try to deal with that. Okay. Yes, tomorrow's classes will be conducted over here only. You want, okay, basic formulas in Excel right now. I guess it will be better if we deal with the Excel concepts tomorrow. Should not be a problem. If Shireel, you want to know about the basic formulas in Excel, we'll try to deal with those formulas tomorrow. We'll try to deal with a couple of basic formulas in Excel tomorrow itself. Yeah, we'll deal with those formulas. We'll cover few textual formulas, few non-textual formulas, and all. Other than that, I guess we are good to close the session. In case there are any further queries, you guys can mention it on the chat window. I'll wait for a minute, and after that we'll close the session. And I would also request you guys to join our Discord server. All the details will be shared over there, and in-depth theories of these topics. Yes, Akansha, if you want, we will be sharing anyway. We'll be sharing the PPT today, and if you have, if you want to understand a few things, maybe you can Google out these things, which is mentioned in the topic which has been shared to you. You can Google out these things, and then you can come prepared. That will be a bit beneficial for you. You can do that. Okay, so okay, so basically how your attendance are getting calculated, and as well as yes, pivot table will be taught to you from very basic sort of. I will ensure that pivot table is taught from very basic. Yes. Yes, Manikandan, we will be teaching you real-time case studies tomorrow. Today's class was a theoretical class, so that people who are not understanding the basic of statistics, these people can deal with that. And from tomorrow's class, we will be dealing with case studies. Yes. Okay, you guys can check the resources which is sent over mail to you, and all the other details will be sent over mail to you people. So basically, all the resources and other things related to tomorrow's session, you guys can check your mail and be prepared with that. So with that, I've come to an end to the session. Thank you so much for having a patient listening. I can see that there are 113-14 people already available. Thank you so much for a patient listening over a weekend. So with that, I'm going to end the stream. Thank you so much.